All right. So continuation from Thursday. So I'm going to do these in a reverse order because I feel like it. So our first one will be 3 over 5x minus 6 minus 5 over 4.
You mean reverse? You just flip the equation.
I just had two examples on my note card. And instead of this one being the second one, I'm deciding to make it the first one. So I don't even know why I said that out loud. Sometimes I just think and then the just comes out. No. Nope. So what's first step? What do we do? The least common denominator is the key to this next little baby unit. So what is the least common denominator of these two? Yeah, and that's overkill, like from the Department of Unnecessary Work, like stuff you don't have to do. It's best to leave your least common denominator factored out. So while I appreciate the sentiment, because we want to see it in its kind of exposed form anyways. So we want to call the least common denominator 4 times 5x minus 6. There really would be no benefit to multiplying it back out. So now we just have to go through, and this is always the routine, and ask ourselves, for each fraction, what does its bottom not have? Like the first fraction, what's its bottom missing? The 4. So we're going to multiply the top by 4. And yes, we are also multiplying the bottom by 4. We just sometimes elect not to show it. And then what about the second fraction? What's his bottom missing? So we'll multiply the top by 5x minus 6. Full understanding that it's happening on the bottom as well. I tend at this point in the problem to really just check out and not even talk about the bottom again for the next little bit. I just work on the top and get it to be the best version of itself. And then when we're done, we'll stick it over the red thing there and see what happens. But in the meantime, our focus is what's in this purple box right here. Okay, so don't worry about the bottom. Like I said, we'll bring it back later. So that's some pretty basic math going on inside the purple box. We have 12 minus 25x plus 30. And watch out, this minus sign right here with the green arrow pointing to it, it will reach out and bite you because it's a distributor. And so it's going to affect all the stuff after it. It's like a -5, not a 5. And so let's clean that up a little bit. So we get negative 25x plus 42 all over 4 times 5x minus 6. And I think I probably should have gone over the weekend. I assumed that was a better example than that, but I really had hoped that there'd be a little bit more meat on that bone. But why is this problem done? Or is it done?
Nothing. Oh, well, you have a factor on the bottom. Could you divide the bottom and the top by 5x-6?
No, and I was so optimistic there for a second, but man, this just fizzled out on me here. I'm really disappointed. This problem is, I'm going to put it in timeout. I really was hoping that something would factor out and that we'd have a conclusion to this, but the bottom line is this. Can anything on the top be divided by 4? No. I mean, collectively, can the both things is what I should have said, and the answer is no. And then is there a 5x minus 6 on the top? And the answer is no. I was holding out some hope, but like, does that thing that I just circled in red, does that have a GCF? No, 25 and 42 don't have anything in common. So for that reason, unfortunately, the problem's over, which is good news because it's less work you have to do. Bad news in that it's really, really quite boring to just get there and go, yeah. And that happens sometimes, but hopefully this last one has a little bit more meat on the bone. Let's find out. You ready? All right, good. Last one, and then we'll do worksheet time. So we're going to do 4x over 3x squared plus 3x plus 6 over x plus 4. Hey, guess what we do first?
You should.
LCD.
LCD.
All these acronyms, I know these stupid abbreviations. We need a least common denominator. Is anyone looking at this suspiciously and wanting to ask a particular question? Okay, let's carry on then. So if you'd asked it, I would have addressed it, but you didn't, so I'm not going to. So what is the least common denominator going to be? Well, I don't know yet, and the reason is because I haven't factored that red thing down yet, right? So what can we do to factor that down? Pull out a 3x, good. So we're going to pull out a 3x, and that's going to leave us with x plus 1. Good, good. So when you look at this now, all of the parts collectively sitting out there, what would you say is the least common denominator? Tell me something that I need in my denominator. I need a 3. I need an x. What else? And I need an x plus 1. And what else do I need? Good. So that's quite a bit going on there, right? There's a little bit of a mess. So what we're going to do is we're going to go through now and just ask ourselves the question. It's like robotic, trained into us at this point. Whatever the bottom is missing, we'll multiply to the top. So in the first fraction, what's his bottom not got? He needs that x plus 4, so we shall give it to the top. Giving it to the bottom, of course, as well. It's just invisible behind the scenes. And how about the second fraction? What does its top or bottom need? You're correct. It needs a 3x, and it also needs an x plus 1. So we're going to give it all of that stuff. Aiden, are you conjuring up a question? I thought no one has asked the question yet, so I'll go back and address it after we're done. It was something that I was wondering if you'd spot at the very beginning. So don't get sidetracked by that right now. I want to we'll come back. We'll come back. We'll come back. Let's finish the course that we're on, the path that we're on, and see where it takes us. So at this point in time, we have to do all of the math in the big funny shaped purple thing right there. Whoop. Make a little notch for that plus sign. So what are we going to get over here on the left side? Nice. The good news over here on the right side is there's no negative to reach out and bite you. It's a plus sign this time, so distribution will never get missed in a case like this. But we should probably clean this up a little bit. I would do the 6 times 3x first. What does that make? 18x. And then let's distribute that. So it's better kind of to combine and then distribute. It just feels better. So what do we wind up with? It's 18x squared. So we'll get rid of all this stuff here, plus 18x. Everybody okay? All right, so now we're just going to do the best we can do to just clean up the top. And there's, if I put the x squareds together, I get 22 of those. And then if I put the linear terms together, I get plus 34 of those. Can I erase a little bit? Is everybody caught up? Okay. So where I'm at in the process right now is, okay, I'm going to take a good, like, hearty look at this. This is my top, and then the bottom is this. So this little conversation that we're about to have will inevitably lead us back to the, oh, we could have done this at the beginning, but you'll see it here in a second. So we want to factor a little bit because honestly, the bottom is already fully factored, but it's the top that has a little bit to offer up. So how could the top be factored down? You could pull out an X. And quite frankly, you could pull out a 2 and an X, but the 2 wouldn't do us any good. So I'm going to bypass it. And I am just going to pull out an X. And I know, listen, that's not a GCF. That's just a CCF, like a convenient common factor. So it doesn't always have to be the biggest because, again, a 2 would have no one to go with on the bottom. So who cares? But if we pull out that X, then we're left with 22 X's plus 34. And that's just some excess junk. But why was it important that we get that X out? Good. And just so you know, we could have done that at the very beginning of the problem. And I want to go back as soon as we're done here. I want to show you what I mean. And it'll just be a good learning moment for you so you can kind of go, okay, I have to remember to watch for this at the very beginning of a problem. But anyways, let's finish the job here. So we're going to take this x on top that we factored out and this x on bottom that we factored out, leaving us with the final answer, which is 22x plus 34 all over 3 times x plus 1 times x plus 4. We're still going. All right, good. So listen, back to the beginning. I'm almost out of color, so I'm going to use a very fat yellow pen to show you something. Back at the very beginning of the problem, that thing in the funny shaped yellow box was the original first fraction. And again, I didn't know if right at that moment if anyone was going to spot it. But the answer to the question is yes. Can I reduce a fraction before the problem even starts? And the answer is yes. You could have taken an x out of the top of this fraction, and you could have taken an x out of the bottom. And all the stuff we did at the bottom by having to refactor out that x, it could have been avoided in the first place if we had just spotted it earlier on. I assume that that's what you had identified. So watch out for that. And again, I was kind of on high alert there to see is anyone going to grab it. And when you didn't, I just hauled on past it. But watch out in the future. So does it happen a lot? I don't think so. But if it does, I would take advantage of it early. So if I've lost anyone, what I'm trying to say is that this thing in the yellow box, really from the beginning, if we pulled an X out of all three terms, essentially, it would have wound up looking like 4 over 3x plus 3, and then you can carry on your merry way from there. Make sense? Okay, good. So that's all I've got for you. I'll keep this alive like I always do, but I'll hand out the paper and then you can just work, work, work. And if you have questions, you'll let me know. Yeah. Okay, so we've got 2n over 3 plus n minus 4 over 3 times 2n plus 1. So this is what problem 1 looks like if I factored the bottom, because that's what I'm supposed to always do. Okay. Factoring the bottom is like 100% essential so that you can see the pieces of the factor or the denominator so you can find the common. So when I see it factored like this, I realize now and you realize now that to be a common denominator, I need to contain a 3 and I need to contain a 2n plus 1. I don't need 2 3s. If I just have one, that's common to both, and that's all I need. It covers them both. Do you have any questions so far? Okay, so now we're just going to do the thing where we say, what's the bottom missing? Play the little game. The first fraction, I look at the bottom and I say, well, you, sir, do not have a copy of that fine-looking 2n plus 1 over there, so let me get you one of those. So I'm going to multiply it by 2n plus 1, like that. Whatever the bottom needs, the top gets. What about the second fraction? What's its bottom need? Nothing. So now we're going to just take and we're going to work out the math problem in the funny purple shape. I'll just keep drawing the funny purple shape until it drives the point home that your concern right now is that, not the bottom, but that. We know what the bottom's going to be. It's written in red over there on the side of the screen. So that is going to be 4n squared plus 2n plus n minus 4. I didn't want to skip any steps at all. So what does that wind up being? So we have 4n squared plus 3n minus 4. And it's all over 3 times 2n plus 1. So this is potentially the final answer. But I feel like once you decide to take a math class like this, like I sometimes wonder why certain people take algebra 2. And then I really think by the time you sign up for this class that this math thing must mean something to you. So having said that, I'm going to show you again. Boy, wouldn't it be nice to know if I could factor the top without sitting around and trying every possible combination. And this is where that test that I've shown you on multiple occasions, but I'm always happy to show you again. It comes in so handy because it tells me if the top is a waste of time or not. Do you guys remember the test for factorability? Good. So the test goes like this, because this won't be the last time you look at a polynomial and go, gosh, I wonder if I can factor it. So you take the number in front and the number in back, make sure you include the sign, and you multiply them together. You could do all this in your head. What's 4 times -4? So you ask yourself simply, are there numbers, whole numbers, integers, that multiply to make that yellow number and add to make that red number? Are there? Then it's not factorable. If the numbers that you seek do not exist, you don't have to spend time wondering. And the reason I'm bringing this up is because imagine if the top had been factorable and then we missed a common factor of 2n plus 1. Then the whole problem is shot and ruined. But now we know it would have been a waste of time to even try to factor the top, because the test tells us, don't even bother. It ain't happening. So the final answer is already on the board. It's right here in this white box.
Could you explain the test?
I would love to, yes. So let's say we had something like this. If anyone else is interested in the test for factoring, I would be glad to show you again and again and again. Let's say I wind up at the end of a problem with something like this. And it's over, that doesn't even matter. And I'm wondering if I can factor this down. So we go like this. We take the number in the front, +3. We take the number in the back, which is -8, and we multiply them together. What do we get? We do. And so now we ask ourselves a question. Are there numbers in the known universe that multiply to make that and add to make that? You follow? So you create the first half of the test by multiplying the front and back ends. And then that gives you a target. You say, okay, I got to multiply to make that. And then the other part of it is, can I add numbers that have to satisfy both of these requirements, but they have to add to make this? And then a bright fellow like yourself quickly realizes, yes, those numbers do exist. If I had a +8 and a -3, they multiply to make -24, and they also add to make 5. So what that means is that going down this road is not a waste of time. It means that this factoring exists, and finding it is probably going to be a benefit, because people like me write problems where if it's there, we want you to find it for a reason, right? So what I think about is I say, okay, well, if I put it like an 8 here and a 1 here and like a plus here and a minus here, like we've factored hundreds of times before. And then imagine how beneficial that would be if then the bottom of the fraction had been like 2x minus 2. Because if we didn't see the factoring, then what we wouldn't see is that the bottom is actually 2 times x minus 1. And had we not taken that time to find those common factors, we never would have spied that. Was that a satisfactory explanation? Mm-hmm. So multiply first number, last number, make sure you include the signs, and then ask yourself, are there numbers that multiply to make what I just got and add to make what's in the middle? Rad. Okay. So this is number 4, and there's really nothing right out of the gate. If I had written this problem on a test, math teachers don't do this to be mean. We do this to, we set traps not in the hopes that kids will fall in them, but in the hopes that we've taught them well enough that they won't, if that makes sense. So if I put this on a test, my first thought would be, is anyone going to do this? Right. And that's when a kitten dies, right? Like, we know we're not going to fall for that kind of garbage. So, so beyond that, it's a very unexciting start to the problem. Do you know what the least common denominator is? It is. It's completely unexciting. There's nothing, the bottoms can't be factored. I hope the problem gets more interesting than this as we go, but I guess we're going to find out. So once we know what the target is, what is the least common denominator, then our objective, we always shift into the mode of saying, how can I make it? And so go to the first fraction, what's his bottom missing? So we're going to multiply the top by whatever the bottom needs. And then we get to the second fraction, and what does its bottom need? An x plus 4, so we'll multiply it to the top. So if as a teacher, test number 1 that I would have wanted every kid to pass was, for God's sake, don't cancel out those 5x's. Test number 2 is about to arise. And I'll tell you, having graded problems like this hundreds and hundreds, if not thousands of times, I'll show you what the most common mistake is. First off, you do understand now that we're working in the purple box, right? Okay, nothing else matters, just the purple box. So I'll show you if someone put a gun to my head and said, someone missed this problem, quick, you have 30 seconds, tell me how they missed it. I would put all my money on the following. Someone went 25x minus 15 minus 5x squared plus 20x. And that's wrong. Do you see it?
It's -5.
There is. And so this distributor, the thing in the green, is a negative, and that negative affects everything after it. And so the hard part about this, like, I know everyone knows how to distribute. It's just when that minus sign is kind of sitting off to the side like that, we tend to forget that it's a negative. So we're distributing a negative 5x, which makes it negative 5x squared and negative 20x. So this needs to be a minus sign. Still with me?
Yeah. Not that, it was not that.
What was it?
I put it as 5x plus four, so I ended up like I made it, so then it ends up with like the whole 5 at the whole top, and then I was like, that's not right. Because I put like, I think it has like 5x plus 4, so it's like negative.
I'm interested to see if anything comes of this. So I'd kind of like to finish with you. Do you mind? Okay. So I'm glad you're such a competitive person. I appreciate how excited you were to tell me that that was not the mistake you made. So good job. So I'm going to clean up the top a little bit. I'm going to call it negative 5x squared plus 5x minus 15. You can, but it's fun. And the more of this we practice over the coming days, the more we realize that, a dork like me will say you have to factor, factor, factor. But then the same dork will tell you sometimes it's good to know when you don't actually have to factor. So, and we'll learn this through experience, but the bottom looks like this. And so I will do what I know the math gods are telling me I should do, and I'm going to pull a negative 5 out of the top because it just feels like that's something I've got to absolutely do. So if I pull a negative 5 out of the top, that turns it down to x squared minus 1x plus 3. Are you with me so far? So had I handcrafted this problem, I probably would have worked a little harder to make something exciting happen, but you don't need the test for factoring. That thing I just showed you with the yellows, all that stuff, you don't need it for this because like we've done enough of this to know that that can't be factored, right? That ain't happening. And so for that reason, this answer is done.
So would you factor it out or leave the other?
That's a good question. So that's if you left it like this, I would be okay with that just because that would, as long as you left it like this because you saw the writing on the wall. My take is like, did it hurt anything to pull out the negative 5 and let ourselves get a better look at it? No. So I would take either answer just because the factoring wouldn't have served a purpose, Blair. Am I making sense? Okay. I feel like you might as well factor it just to say then that I gave it a fair chance because to miss something that could have been canceled by not factoring, now that would be a really bad thing.